Hey, welcome back. We're going to go ahead and take a look at the second part of the Unit 4 test review. Here's an image. Determine the transversal for the following angle pair and name the angle pair. So, when I'm trying to determine the transversal, basically, remember the transversal means the line that cuts. And whatever these angles share, that's the transversal, okay? And then the next thing, we're going to go ahead and name the angle pair, which is basically the corresponding angles, alternate exterior angles, alternate interior angles, and same side interior angles, so on and so forth. So, actually, there is no so on and so forth, because those are the angle pairs that we've already discussed. So, yeah, let's go ahead and take a look at number 7, angles 2 and 7. So we can see 2 is right here, 7 is right there. 2 shares this line, and 7 shares this line here. But notice that 2 and 7, they both share this line. Okay, so if I were to draw the picture, okay, again, 2 is part of this line and 7 is part of that line. The transversal in this case is line M. So then here's 2 and then here is 7. They both share the line M. So then the transversal is line M. And I notice that 2 and 7, they are alternate, and they're both inside of the parallel lines. So the angle pair name would be alternate interior angles. Okay, alternate interior angles. Okay. Let's go ahead and take a look at number 9. Actually, let's go ahead and do number 8. Determine which lines would be parallel given the following information. State your reasoning using a theorem or postulate. So this here is definitely using the converse theorems. And remember, with the converse theorems, they prove lines parallel. So they prove lines parallel. So go ahead and use your pink sheets for that. So angles 2 and 7. If angles 2 and 7 are congruent, right? So here I'm going to go ahead and draw my lines again. So here's 2 and then here's 7. Angles 2 and angle 7 are congruent, and they are both alternate and in the inside of these lines. We cannot assume that these lines are parallel. So if these angles are congruent and they are alternate interior angles, then by one of the converse theorems, these lines are parallel. We cannot assume from the beginning that they are parallel, right? We have to determine the steps first before we do make that judgment. So again, angles 2 and angle 7 are congruent, and they are both inside of the lines here. Therefore, line J and K are parallel, okay? So the parallel lines in this case are J parallel to K, and we say that they are parallel because of the alternate interior angles converse. Okay? So please make sure that you know the difference between the original theorems versus the converse theorems, okay? Let's go ahead and take a look at number 9, 10, and 16. So 10 is here, 16 is here, 10 is part of this line, 16 is part of that line, but 16 and 10 share this transversal. So 10, 16. Notice that 16 and 10 are alternate, and they're both outside of the parallel lines, okay? So then we say that the transversal is line N, and the angle pair will be alternate exterior angles. Alternate exterior angles, okay? So now, we're going to go ahead and do number 10, where we cannot assume that these lines are parallel. So J and K are no longer parallel until we follow the criteria. So in this case, angle 10 is congruent to angle 16. So if angle 10 is congruent to angle 16, and they are congruent, and they are alternate, we can see that they are alternate, and they're both outside of these lines, okay? So if that's the case, then these lines are now parallel by the converse theorem. So the parallel lines in this case are J and K. So I write J is parallel to K. Oops, I meant to write it over here. And the reasoning would be alternate exterior angles converse. Okay? So that's how you do that. And now let's go ahead and take a look at number 11. Angles 14 and 19. 14, and then where's 19? Oh, sorry, that's not 19, that's a 9, sorry. 14 and 9. 14 is part of this line, 9 is part of that line. 14 and 9 share this particular transversal, so let's go ahead and draw it so we can see it. So here's J, here's K. This is line N, so 14 and 9. Notice that these lines are parallel, cut by a transversal. 14 and 9, they are on the same side of the transversal, and they're both inside. So that means that they are same side interior angles, and the transversal would be N, because that's what they share. So I write N, and then I write same side interior angles. Okay? So now, just by looking at this, measure angle 14 plus measure angle 9 is equal to 180. So now, since we're doing this part now, we cannot assume that these lines are parallel. Okay? So here, measure angle 14 plus measure angle 9 is equal to 180. We can assume that because that's our given. So one of our converse theorems, the same side interior converse theorem, states that if you have two lines cut by a transversal and you have same side interior angles, then the lines are parallel. Okay, so we can see that yes, 14 and 9 are same side, and they add up to 180 based on the given. Therefore, J is parallel to K, and the reason would be same side interior angles converse. Okay, now let's go ahead and move on to number 13, where I have angle 1 and angle 13. So we can see that 1 is part of this line, and 13 is part of this line. What do 1 and 13 share? They share J. So that means if we draw the lines, we assume that they're parallel. These are parallel lines cut by transversal. I'm going to label M, N, and then transversal is J. So if I compare one region to the other region, if I were to stand at 1, then in the other region, it's like saying you're standing at 13. Okay, so that is what we call corresponding angles. Okay, so now we assume that these lines are parallel for number 13, and when I get it to 14, we cannot assume that these are parallel. But I notice that from the given that angle 1 is congruent to angle 13. And since I have these two lines cut by a transversal, and angle 1 and angle 13 are basically corresponding to each other, then we can say that lines M and N are parallel. And the reason would be corresponding angles converse. Okay, like I said, the converse theorems prove lines parallel. The converse theorems prove lines parallel. Okay, so now let's go ahead and take a look at this proof here. Write a 2-column proof for the following. Given that given that M is parallel to N and J is parallel to K, prove that the measure angle 1 plus the measure angle 10 is equal to 180. So the given is what we can assume. So I'm going to go ahead and mark on my picture that M is parallel to N, right? So here's M, here's N, and then they are parallel to each other. So I'm going to go ahead and draw these arrows to show that they're parallel, and also that J is parallel to K. So I'm going to use 2 arrows to indicate that they are parallel. Okay, so I'm looking at the proof right now. That is my goal. I need to prove that measure angle 1 plus measure angle 10 is equal to 180. Okay, so here, if I look at my picture, 1 is right here and 10 is right here. And since this is equal to 180, I know for sure that the only thing that we have talked about that deals with 2 angles adding up to 180, one of the theorems was the same side interior angles theorem, right? So this here, they have to be supplementary, okay? And if I can use something to get to same side interior angles, I think I am golden. So let me go ahead and look back at the picture, okay? So again, here's 1 and here's 10, right? I have parallel lines cut by a transversal, cut by another transversal, or parallel lines cut by this transversal and that transversal, right? So just by looking at the positioning, 1 is over here, 10 is over here. If I can figure out how I can, like, get this to be the same side, right, then I think I have an idea on how to approach this proof. So what can I see here? Well, if I were to look at this, so here's 1, and then here's this other line parallel to wherever 1 is, so this line J, and it's cut by this transversal here, right? If we notice that here's 1, that's basically 8, right? Because that's the alternate exterior angles theorem. So we can say that angle 1 is congruent to angle 8 by the alternate exterior angles, theorem right here. So this is congruent to angle 1. And notice that here I have 8 and 10. And that's exactly what sort of, when we get into that, it's kind of the same, because 8 and 1 are the same. They are same side. Those 2 angles here, they're supplementary to each other, right? Same side interior angle. So I think I have an idea on what to do. So let's go ahead and approach the proof now. We see the statements here, the reasons. M is parallel to N, J is parallel to K. These are the things that we can assume, and that's my given, right? So basically, the reason will always be given, okay? And then here, alternate exterior angles, we said that 1 and 8 are pretty much the same, right? So by the alternate exterior angles theorem, I say that angles 1 is congruent to angle 8. And then going from, this is currently geometry language, and now Because look at this. This stuff is all algebra stuff. So I need to convert from the language of geometry to the language of algebra. That is me using the definition of congruence. Okay. So now I have that. I can say that measure angle 8 and measure angle 10, right? They are same side interior angles. Because if I add these two angles up to each other, they are same side interior angles. Has to be. These angles are same side interior angles. If I were to draw, here's 8, here's 10, and this is the transversal K, and then MN is here. These are same side interior angles. The measure angle 8 plus the measure angle 10 is equal to 180. But my goal here now, my goal is to prove that the measure angle 1 plus measure angle 10 is equal to 180. But y'all, we said that measure angle 1 is measure angle 8, or vice versa. Measure angle 8 is measure angle 1. So all I had to do is, if I approach this proof, I can replace that measure angle 8 with measure angle 1. And then I just leave everything else intact. So measure angle 10 is equal to 180. And all I did, I was replacing stuff, right? Well, just one thing. Measure angle 8. I replaced measure angle 8 with measure angle 1. The prove should always be this last box, and you're going to provide that reasoning right there. Okay, so now I'm already done with the proof. I actually want to go ahead and just pause for a bit because I think there's a mistake on this review. Well, first of all, we cannot say that these are same side interior angles. That's not the reason. But y'all, we did say that angle 8 and angle 10 are supplementary. So we should, right here, for the statements right here, we should say that angle 1, or I should say angle 8 and angle 10 are supplementary by the same side interior angles, right? So then when I jump into measure angle 8 plus measure angle 10 is equal to 180, this would actually be definition of supplementary angles. Okay? Then I can say, by replacing, we know that measure angle 8 is measure angle 1. So it's measure angle 1 plus the measure angle 10 is equal to 180. That's me just using substitution. I will use the prove, and I just copy and paste it right there, and then you're going to go ahead and provide the reason, okay? So, yes, when you notice that the angles are supplementary, write that down. That's because of the same side interior angles. You do not write measure angle 8 plus measure angle 10 is equal to 180. That's the definition of supplementary angles' job. That's the reason. So, I just caught that mistake just 2 minutes after I made that original part, and I'm editing this part to that video at the end, okay?